Okay. So, next so previous example is little bit of nothing to be confused actually, just see very carefully, it is a this example is a very unique example actually, and just you try yourself to derive that thing, and most of the things I have derived and I told you how to do it, but if you give elaborate your derivation, then it will not be, it will be very lengthy procedure, and it will consume more time in a video course, a video lecture class, right. So, next is that your simplified model with amorphous neglected, right. So, first we will take a simplified model. So, with the amorphous neglected, the stator voltage equation, that is equation 192 and 193 are unchanged, but the remaining equation 121 to 131 simplify as follows, right. So, your what you call that your from equation 121 to 131, so total 11 equations, right. So, because we are neglecting the amorphous terms, if you do so, this is not required for you, this is for my reference, right. So, psi d is equal to, okay, let me move little bit up. So, flux linkage first. So, psi d is equal to minus L d I d plus L A d I F d with amorphous neglected. This is not for you, this is for my reference, right. So, psi q is equal to minus L q I q, this is equation 197, and psi f d is equal to minus L A d I d plus L f f d I f d, this is equation 190. All these nomenclatures have been given before. So, right. So, next is the rotor voltage equation with amorphous neglected. So, in here E f d will be P psi f d plus R f d I d, right, or this P psi f d or P psi f d is equal to, just rewrite this equation, is equal to E f d minus R f d I f d, this is equation 199, this is not required, this is for my reference, right. So, next we will make that alternative form of machine equations, because we have to make it in that block diagram, whatever we have started it will slowly and slowly it will, block diagram will grow, later you will see. Now, alternative form of machine equations. Now, equations 196 to 198, this will write little bit different way, are often written in terms of the following variables, right. That is E I, we define a variable E I, E suffix capital I is equal to L A d I f d, that is voltage proportional to I f d, right. Another term we write capital E q dash is equal to L A d upon L f d psi f d, that is voltage proportional to psi f d. Another term we write capital E f d L A d upon R f d into your E f d, that is voltage proportional to E f d, because we have to simplify the whole mathematical derivations, right. So, we represent like this. So, in terms of the new variables, equation 196 will become, that means whatever we have seen here, equation 196, 197 and 198, right, all these things in terms of new variables, it will become that your psi d will be minus L d I d plus E I, this is equation 200, right. So, this is not required, this is for my reference. So, and multiplying equation 198, you multiply equation 198 by L A d upon L f f d, right, and throughout and expressing in terms of the new variables, then you will get E q dash will be minus L A d square upon L f f d I d plus E I. You just equation 198 multiplied both sides by L A d upon L f f d, and then you simplify and whatever assumptions we have made, right, and then you can get E q dash will be minus L A d square upon L f f d I d plus E I. This is equation 201, right. So, now this one we cannot, you are what you call, we are not interested to prove this one, right. So, you assume L square A d upon L f d L d minus L d dash, this is actually, it can be derivation is there, but I will skip that one. We will assume that L square A d upon LFFD LD minus LD dash, right. And when you listen to the lecture, if you need the your what you call that explanation of this one, then we will put it into the forum, right. But otherwise what will happen, the continuity of this your topic will be lost, right. That is why L square A d upon LFD, it is LD minus LD dash, like your XD double dash, XD dash, subtransient, transient, steady state reactances, right. So, it can be proved LD minus LD dash. So, L square AD upon LFFD. So, but if you have anything you put in the forum, we will explain, but here we will not, then continuity will be lost, right. So, that is why I have written, we know L square AD upon LFFD is equal to LD minus LD dash. This also you should keep it in your memory, right. So, if it is so, then EQ dash, it can be written as EI, that is capital E suffix capital I, minus in bracket LD minus LD dash ID. This is equation 202, right. This is other things for my reference, right. Now, what you do now, multiply equation 199 by LAD upon LFFD throughout, right. I mean left and right side both, right. If you do so, then we have, that is P into LAD upon LFFD psi FD is equal to LAD upon RFD into RFD upon LFFD EFD minus RFD upon LFFD LAD into IFD, right. Or this term we have assumed, this thing it will be P EQ dash will be equal to 1 upon actually T DO 0 dash into EFD minus EI, and this is your this is TDO dash is equal to LFFD upon RFD. I am not telling this term. So, this is a question to you, what is your TDO dash? It is time constant of course, but what is the full form, right, it is time constant. So, this is a small question to you, that TDO dash is equal to LFFD upon RFD, right. And if you multiply and simplify, this equation will simply become that 1 upon T DO dash EFD minus EI, this is equation 203, right. So, this is your what you call that basically it is nothing but EQ dash dot, right. So, now the following is the summary. So, summary is that psi d is equal to minus LD ID plus EI, psi q is equal to minus LQ IQ, EQ dash will be EI minus in bracket LD minus LD dash ID, right, and P EQ dash will be 1 upon T DO dash in bracket EFD minus EI. This is the summary, right. Now, phasor diagram for transient condition, right. So, in order to do this, this is first necessary to express EQ dash EI and EQ in terms of D and Q axis component of terminal voltage and current, because we have to this representation that your phasor diagram for transient condition we want. So, if you do so, that your express EQ dash EI and EQ in terms of D and Q axis component of terminal voltage and the current, right. So, in per unit XD is equal to LD, I told you in per unit reactance and inductance are same. So, from equation 193 and equation 196, right, we will write like this. So, we will replace LD dash by XD dash, right. So, it will be something like this, that EQ, that in equation 193 to 196 EQ will be psi d minus RA IQ. This is same as before, right. EQ will be, instead of LD we will write XD minus XD ID plus, instead of LAD we will write XAD IFD minus RA IQ, right, because in per unit inductance and reactance are same, right. So, EQ will be minus XD ID plus capital E suffix capital I minus RA IQ. This first you will rewrite, right. Therefore, we can write, therefore, EI is equal to EQ plus J XD ID plus RA IQ, right. Therefore, EI will be EQ plus your, I mean from this equation EI will be EQ plus, I mean from this equation it is coming, from this equation only here it is writing EI is equal to EQ plus XD ID plus RA IQ, right. Now, multiply both sides by J, right, that is the complex operator. If you do so, it will be written as JEI plus is equal to j eq plus j xd id plus j ra iq, right. So, in terms of phasor notation, then this one can be written as E I tilde is equal to j eq can be written eq tilde, right, and j xd id can be written xd id tilde. It is not there, this term will be actually xd id tilde, right. So, it will be xd id tilde, this j is not there, it is when I writing by mistake I made it. So, it will be xd id tilde and j iq can be made ra iq tilde. That means, for your understanding that E I tilde is actually j e I, right, because we have to represent by phasor quantity. Similarly, your small e q tilde is equal to j e q, right. Similarly, your I d tilde is equal to j I d, right, and similarly your I q tilde is equal to j I q, right. So, just to represent that all a tilde is given, these are phasor quantities. So, this way we can write, and this is nothing, this is for my reference, and this is actually equation 204, right. So, we will go to the, just hold on, we will go to the next page. So, similarly, your for equation 202, right, with x d dash is equal to L d dash, because I told you in per unit reactance and inductance are same, right. Therefore, you can write, if it is so, then E q dash will be E q plus x d I d plus R A I q minus x d I d plus x d dash I d. So, this x d I d and x d I d will be cancelled. That means, E q dash will be E q plus x d dash I d plus R A I q. Now, if you multiply both sides by j, the complex operator, so it will be j e q dash, it will be j e q plus j x d dash I d plus j R A I q. Now, before going to the next page, so we will define that your same as before, the phasor quantities, the E q dash, your E q dash tilde, it is E q dash tilde will be j E q dash, right. Similarly, your E q will be, E q tilde will be j E q, right. Similarly, your I d tilde will be is equal to j I d, right, and similarly here I am writing that I q tilde will be j I q, right. So, because we are because we have to represent the we have to draw the phasor diagram and the transient condition. So, you have to put them in the phasor form. So, that way you can write. If you do so, then next equation will be in phasor notation, it will be your E q dash tilde, E q dash tilde is equal to E q tilde. I told you this j should not be there, it will be x d dash I d your tilde, this should not be there, right, then plus R A I q tilde, this is equation 25, this is nothing, this is for my reference, right. So, that way first we make this one. After this, we see that the phasors E I tilde and E q dash tilde both lie along the q axis, because multiplied by j only, right. So, we have also seen that the E q your tilde also lies along the q axis, because all we multiplied by j and all are lying actually along the q axis, right. So, what you can do is that if you rearrange equation 167 and substitute E I for x a d I f d, that go to equation, look, this is this again and again it is difficult to go back to that equations, then this is for my reference, nothing required, that it is difficult to go back again and again, but when you are reading this I mean listening this lecture, at that time notes also will be available, right. So, everything will be uploaded. So, at that time see the equation 167 rather, and substituting E I for x a d I f d, then you will get E I tilde is equal to E q tilde plus j x d minus x q I d tilde. This is very simple thing actually. I mean just you put it and you will get it. By chance if you stuck somewhere, you just put a question to the forum, answers will be given there, right. Absolutely there will be no problem, right. So, in that case you will get E I tilde is equal to E q tilde plus j into x d minus x q I d. This is equation 206, right. Now, after doing all this, figure 19 actually shows the phasor diagram representing EQ dash tilde, EQ tilde and EI tilde given by equation 204, 205 and 206. So, this 204, this equation previous 204 has gone to the previous page, 205 and 206, right. If you draw the phasor diagram, the phasor diagram will look like this, right. I mean, just hold on, if I can reduce the percentage little bit, then all. So, here it is accommodated, right. So, in this case, if you see this, that this is my q axis for my own drawing, this has been taken q axis such that, and this is your d axis, this is your d axis, right. Such that drawing will be, phasor diagram drawing will be in an easier way. So, this EI tilde, EQ tilde, EQ dash tilde and EQ tilde and of course, IQ tilde all are your what you call lying on that your q axis, right. And if you look into that EI tilde is equal to EQ plus XD minus XQ ID, because just now we have seen that EI tilde is equal to EQ plus XD minus XQ ID. So, this is your, this portion is XD minus XQ ID, and from here to here this is the, and this voltage is ET tilde, right, and this voltage is E dash tilde, right, and this angle that is between your what you call this E or what you call that ET tilde and EQ tilde or EI tilde or EQ dash tilde, whatever it is, this is that your delta I, this angle is delta I, right. This we have seen earlier also, and this is the current I2 tilde. So, current is lagging from ET, right, because this is ET tilde and this IT tilde. So, this current is lagging and this is your ID tilde and ED, this is D axis, right. So, that means, and this current is IQ tilde, all are along the q axis. So, if you now, and this term, this your from here to here, this term is XQ ID, this we have seen, just look at those three equations, you will get it, this term is equal and this term is RAIQ, right, this term is RAIQ, I mean from here to here, because this is my IT and this is my ET tilde. So, this term is actually, this term is RAIQ, just see those equations, I mean you will simply get it like EQ dash tilde is equal to EQ tilde plus RAIQ plus XD dash ID, all these things are there in the equation. So, I could just see the equation and just make this phasor diagram, and this term your JXD ID IT tilde, right, and from here to here this is JXQ your IT your tilde, right. So, just see those three equations and just make this phasor diagram. This phasor diagram is under transient condition, right. So, all these things are drawn, just you have to open the notebook and you have to make it, right, from those three equations. So, just for your reference I have written that ET your what you call that your, I am now little bit zooming it. So, ET just hold on. So, ET tilde is equal to ED plus JEQ is equal to ED tilde plus EQ tilde, this way we write, right. So, whatever has been drawn here, and similarly E dash tilde is equal to ET tilde plus RA plus JXD dash IT, because you are replaced, we have replaced LD dash by XD dash, right, IT tilde, and EQ dash tilde, that is q axis component of E tilde dash or E dash your E dash tilde, right, is equal to EQ tilde plus RA IQ tilde plus J XD dash ID your what you call here one thing is there, it should not be there, it is XD dash ID tilde, right, this should not be there. Now, at EQ tilde is equal to voltage behind RA plus JXQ, it is voltage behind RA plus JXQ. So, here also one J should not be there, it is ET tilde plus RA plus JXQ, oh no, here I have multiplied by this thing, sorry, here also sorry, just hold on, here actually it is multiplied. So, RA your what you call your q axis component, the EQ tilde RA IQ plus J XD ID your tilde, right, and similarly your this thing your EQ tilde voltage behind RA plus, it is ET tilde plus RA plus JXQ IT. So, it is EQ tilde plus RA IQ, no, this should not be there, it is correct, right, it is correct, because we are making already ID tilde and this is IQ tilde and this is ID tilde and this is IQ tilde EQ tilde, all are in phasor quantity, right. So, this J should not be there. So, similarly, your EI this thing your tilde is equal to EQ tilde plus J XD minus XQ ID tilde, right. So, this is your figure 19, that is this is the figure 19, right, this is your synchronous machine phasor diagram in terms of EQ EI and EQ dash, right. So, that is your what you call, that is your phasor diagram, and this is your XQ and this is ID. Let me have a look, XD XQ IT tilde. So, this is the phasor diagram. Now, next is that constant flux linkage model, right, for studies in which the constant flux linkage model. So, before going to your constant flux linkage model, I will suggest that just have a look all these things once again, right, and throughout all the derivations are there. It is basically, you know, that power system dynamics control course is basically synchronous machine course, and huge mathematics is involved. Later we will see much more mathematics, right. If you see by chance if I had made any error, even anything is there, you please put the question in the forum such that I can rectify myself, right. So, this is one thing. So, so many things we have made, J operator and other thing. If you see anywhere I have made any error or anything, you just please your what you call put that in the forum, right. So, next is constant flux linkage model. So, for studies in which the period of analysis is small in comparison to TDO dash, the machine model is often simplified by assuming EQ dash or the psi FD constant throughout the steady state period, right. Now, this assumption eliminates the only differential equation associated with the electrical characteristics of the machine. A further approximation which simplifies the machine model significantly is to ignore transient saliency by assuming XD dash is equal to XQ dash, and to assume that the flux linkage psi 1 q associated with the q axis rotor circuit corresponding to XQ dash also remain constant, right, because we are going for your constant flux linkage model, right. Now, with these assumptions, the voltage behind the transient impedance, that is RA plus J XD dash, has a constant magnitude, right. The D and Q axis equivalent circuit with only one circuit in each axis are shown in figure 20, right. So, if you the D and Q axis equivalent circuit with only one circuit in each axis are shown in figure 20. That means, this actually it is analogous to your what you call the DC circuit, that this is psi D. Whenever showing arrow means it is positive and no arrow means it is negative, and this is psi AD, and this is actually actually psi FD, and current through this actually IFD minus ID, right, and this is actually plus minus, this is psi FD and this is LFD. So, it is something like your what you call that analogous to DC circuit. So, this is D axis and this is Q axis, this is psi 1 q, this is L 1 q, and this is psi AQ, this is psi q, and this is IQ, and this is LL, and this is also capital L suffix L, and this current is ID, this current is IQ, and this is actually LAD, right. So, the D and Q axis equivalent circuit with one rotor circuit in each axis. I mean, whatever equations we have seen before, this way you can represent, I mean, if you can put the circuit like this. So, it will be analogous to a DC circuit, right. So, from this also you can write all this equation. For example, sorry, for example, psi AD will be LAD into IFD minus ID, right, and you can apply KVL also. If you apply KVL, for example, if you apply KVL, say here if you apply KVL, so it will be LL ID plus psi D minus psi AD is equal to 0. This equations you have seen, and similarly if you write psi AD from here, it will be LAD into IFD minus ID, right. And here also you can apply in this mesh also you can apply KVL, right. So, whatever equations we have written this way, you can represent the circuit, right. So, now the per unit flux linkage identified in the dx is given by your psi AD is equal to minus LAD ID plus LAD IFD. That means this one we are right directly, you can write psi AD is equal to LFD into IFD minus ID, then you multiply and you simplify, it will be psi AD is minus LAD ID plus LAD IFD. Similarly, psi D will be, I told you the KVL, that psi AD minus LL ID, and similarly psi FD will be psi AD plus LFD IFD. I mean here there should not be any confusion here, this current is IFD, actually this in this branch current is IFD minus ID. Now, if you apply your KVL, right, if you apply KVL say anticlockwise, then your it is LFD, then your IFD, LFD IFD plus LAD, then IFD minus ID this term, then minus psi FD is equal to 0, because this plus, this is minus psi FD is equal to 0, and you simplify, right. So, if you do so, you will get psi FD is equal to psi AD plus LFD IFD. This is equation your what you call 209. So, this is nothing, this is for my own reference, this is nothing, this is 270, 207, 208, 209, right. And from equation 209, from this equation you can write IFD is equal to psi FD minus psi AD upon LFD, this is equation 210, right. So, if you substitute in equation this one in equation 207, that means this equation you substitute for IFD. If you do so, you will get psi AD is equal to minus LAD ID plus LAD upon LFD in bracket psi FD minus psi AD, right. So, therefore, we simplify this one, we can write this equation like this, that psi AD is equal to LAD dash in bracket minus ID plus psi FD upon LFD. This is equation 211, right. Just hold on. So, this is for my own reference, this is nothing for you. So, where you put it and simplify, you will get LAD dash, you can write 1 upon LAD plus 1 upon LFD, and this is nothing but your LD dash minus your LL, this is equation 12, right. Similarly, for the q axis, I mean for this circuit, similarly for the q axis again you apply KVL, you please do yourself, right. I mean so all these things are derived before, but just we have put it that your at the analogous DC analogous circuit, right, for that flux linkage equation. So, this is from this your what you call from this figure only you can get like this, right, this one. Similarly, for the q axis, only that from that figure you write those equations and simplify, you will get psi AQ is equal to LAQ dash in bracket minus IQ plus psi 1Q upon L1Q, this is equation 213, right. This is nothing, this is for my reference. So, where LAQ dash is equal to LD dash minus LL, right, same as before. So, from equation 190, the dx stator voltage is given by ED is equal to minus RAID minus omega psi q. We go back to equation 190, right. So, and therefore, ED is equal to minus RAID plus omega and psi q is equal to LLIQ minus psi your what you call psi AQ. From that q axis that your analogous circuit diagram is there, from there just to apply KVL, that psi q is equal to LLIQ minus psi q. This is from figure 20 I have written here, that means from here, that means from this figure, from here, right, from this figure you apply, it will look, it will, if you apply KVL, I am telling from my mouth, it will be LL into IQ plus psi q minus psi q is equal to 0. From there you substitute, right, from there you substitute that your this thing, this is, that is why it is written from figure 20, and where omega is equal to omega r is equal to omega 0, say 1 per unit, all are same. So, if you and substituting for psi q from equation 213, right, you do this, you will get psi your what you call that this is nothing, this is no, you need not this is nothing for you, this is no need, right. You better you skip this one, go to the next page, this is nothing for you, right. So, go to next page, then you will see that E d will be equal to minus R A I d plus omega L L I q minus omega L A q dash in bracket minus I q plus psi 1 q upon L 1 q, right. Or you will see E d is equal to minus R A I d plus omega in bracket L L plus L A q dash I q minus omega L A q dash in bracket psi 1 q upon L 1 q, or it can be written as minus R A I d plus x q dash I q plus E d dash. Okay. So, next is phasor diagram for transient conditions, right. So, in order to do this, it is first necessary to express that E q dash, E I dash and E q, right, in terms of D and Q axis components of terminal voltage and current, right. So, we know that in per unit that reactance is equal to inductance. So, x d is equal to L d. Therefore, from equation 193 and 196, right. So, whenever you will go through it, that all the previous lecture notes will be available to you. So, immediately you will open that equation 193 and 196, right. So, E q will be small e q will be psi d minus R A I q, right, or E q is equal to substitute expression for psi d, right, previously we have derived that. So, minus x d I d plus x a d I f d minus R A I q, right. So, this term small e q is equal to minus x d I d plus capital E suffix I minus R A I q, right. Therefore, we can write that E I this E I is equal to capital E I is equal to E q plus x d I d plus R A I q, right. Now, question is that multiply both sides by j. If we do so, it will be j E I is equal to j E q plus j x d I d plus j R A I q. Now, in terms of phasor notation, your then basically it is E I. So, whenever we are doing this, I mean before explaining this one, right, just hold on, before explanation of this one, we will go to the next page, right. So, multiply both sides by j. So, it's matter that j means that is your q axis actually leading the d axis by 90 degree, right. So, whenever you make it, so basically E I tilde is equal to your E I, right. This is angle 90 degree, that is nothing but your j E I, right, j E I, right. So, similarly, your E q tilde also is equal to your E q angle 90 degrees. So, j E q, but this j will be there, j x d I d, because your I d actually if q actually leading the your what you call the d axis by 90 degree. So, that is why this I d tilde, then your this I d tilde will be equal to I d, then angle is what, because I d is q, your q is leading, that is your what you call I d. If you take that your I d is the reference one, then it will be angle 0, right. But this j should be there from the phasor notation, and I q also, this I q also along the q axis. So, it is j I q we are taking, that is your I q angle 90 degree. So, it will be actually j x d I d tilde, right. And if you think that I d is the your d axis is the reference one, the q is actually leading the d axis. So, this j should be there, right, in the phasor in terms of phasor notation. So, next we will go to the next one, phasor diagram, right. So, now from equation 202 with x d dash is equal to L d dash. Therefore, E q dash can be written as your E q, then it will be plus x d I d plus R A I q minus x d I d plus x d dash I d dash. So, x d I d and x d I d will be cancelled. Therefore, E q dash will be E q plus x d I d plus R A I q. Here also you multiply both sides by j. So, in that case it will be j E q dash is equal to j E q plus j x d dash I d plus j R A I q, right. So, in phasor notation from the same philosophy, right, from the same philosophy this j should be there. So, it is E q dash tilde is equal to E q small e q tilde plus j x d dash I d plus R A I q tilde. That means your here I am making it, that means your E q dash tilde is equal to basically your EQ dash and angle 90 degree, that is J EQ dash, this is J EQ dash. Similarly for small EQ tilde, right, similarly for IQ tilde, and I told you that Q axis is leading this one, so it will be J X dash ID tilde. So, this is your phase, and this is for my reference, nothing, this is equation 205, right. Now, we see that, just hold on, let me clear it. So, we see that the phasor, just hold on, we see that the phasor EI tilde and EQ dash tilde both lie along the Q axis. We have also seen that EQ tilde also lies along the Q axis just on the previous page. So, rearranging equation 167, right. So, if you, that is, and substituting EI for XAD IFD, right, we get that EI tilde, you go back to equation 167 and your XAD IFD you replace by EI, then you will be EI tilde will be EQ tilde plus J XD minus XQ ID tilde. This is equation 206, right. So, figure 19 shows the phasor representing EQ dash tilde, then capital EQ tilde, then EI tilde given by equation 204, 205 and 206. Now, if you draw the phasor node diagram, this is your Q axis, this is your D axis. So, this is for easy understanding this thing, Q axis actually leading the D axis by 90 degree. So, this is your capital EI tilde, look at all these things, right. So, EI just now we have seen, no, equation 206, EI tilde is equal to EQ tilde plus XD minus XQ into ID, right. Similarly, this is your EQ tilde, this is EQ dash your tilde, right. So, it is basically EQ tilde, small EQ tilde plus RAIQ plus XD dash ID, right. And from here to here this distance is XQ ID, and this is that your current IT tilde, right. And this is your voltage ET tilde, and this portion is RAIT tilde, this portion is XD IT dash your tilde into J, and this is your E dash tilde, and this is your JXQ IT tilde, right. So, this is the, and this angle is delta I, earlier we have explained about delta I, and this is your Q axis component IQ tilde of IT dash, this is Q axis component, and D axis component for this one it is ID tilde, right. Similarly, for your ET, the D axis component is ED tilde, direct axis component, and for ET tilde it is EQ tilde, right. And this one your X axis component is your RAIQ, right. So, this is the complete phasor notation from this your 3 equation 204, 5 and 6, previous page 204 is there, this is 205, and here also J should be there, this J should be there, right, this J should be there, this is phasor notation. So, that is why your this is your that means here at the bottom the ET tilde is given ED plus JEQ is equal to ED tilde plus EQ tilde. So, I told you previously EQ tilde is nothing but JEQ. Similarly, E dash tilde is ET tilde plus RA plus J XD dash IT tilde. So, most of the cases actually you will find RA is very small, right, and it is neglected. So, I will suggest one thing, that neglect RA and redraw the phasor diagram, just neglect RA, and EQ dash tilde is Q axis component of your E dash tilde, right. So, it is EQ tilde, look at the phasor diagram, everything is given the RAIQ tilde plus J XD dash ID tilde, right, because this J should be there, because if you take that ID is a reference, the ID tilde will be actually ID angle 0 degree, right. So, and EQ tilde will be voltage behind RA plus JXQ, that is also given, it is ET tilde plus RA plus JXQ IT, that is EQ tilde plus RAIQ plus JXQ ID, all these things are given in the phasor diagram, and this equation is also shown, and EI tilde is equal to EQ tilde plus J XD minus XQ ID tilde. This is the summary of this phasor diagram, all the equations, and this is synchronous machine phasor diagram in terms of EQ, EI and EQ dash. I think this portion is now understandable for this phasor diagram, right. Just see those equations 204, 205 and 206 and just see how it has been done. The way you draw the single phase AC circuit or 3 phase AC circuit phasor diagram, right, the way you draw a single phase AC circuit phasor diagram, only 3 equations you put in front of you and just see how it is done. So, automatically you can easily draw this phasor diagram. Okay. So, next will be this constant, next it will be your constant flux linkage model. Okay.